Hello, in today's video we're going to be discussing section 6.2, which is going to be an introduction to right triangle trigonometry. So we're going to be talking about the relationships of the angles in a right triangle to their sides using trig functions of sine, cosine, and tangent. To start off, I'd like to recall our relationships with special right triangles. We have two very special types of right triangles, and that would be the 45-45-90 triangle and the 30-60-90 triangle. The reason that these are special is because the ratios of their sides is always going to be the same. In a 45-45-90 triangle, we can call the two congruent sides x, and then the hypotenuse, which is always across from that 90-degree angle, would be square root of 2 times x. Now the reason that we know that this is isosceles is because we have two congruent angles, 45 and 45. Each of those 45-degree angles points to one of two congruent sides. So if I call one of those sides x, then I know that the other is automatically x. To find this hypotenuse, we could use Pythagorean's theorem and say that x squared plus x squared equals the hypotenuse squared. And if we were to solve this for h, we would find that h equals x times the square root of 2, or as we have it here, square root of 2 times x. In a 30-60-90 triangle, we also have ratios that we can identify. The shortest of the three sides from my 30 degrees is x. My second longest side would be across from my 60 degrees, and that would be square root of 3 times x. And then my longest side is always the hypotenuse, which is across from my 90, and that is 2 times x, or twice the length of my shortest side. These are two relationships, the 45-45-90 and the 30-60-90, that you should take the time to commit to memory. We're going to use these relationships to fill in the missing sides in each of these following triangles. In my first triangle, I do see that it's 45-45-90, meaning that the two legs, or in other words, legs are the sides attached to my 90-degree angle, those two legs are congruent. So this bottom leg must also be 5 meters. The hypotenuse of a 45-45-90 triangle is equal to the length of a leg times the square root of 2, which means that this hypotenuse is going to be 5 times the square root of 2 meters. In a 30-60-90 triangle, the shortest side is always our x, so I do know that x is going to be equal to 3 feet. I know that the longest side is my hypotenuse, and that is going to be 2 times my x. So here hypotenuse is 2 times x, which would be 6 feet. And then I know that the side across from the 60 degrees, as it's already written for you here, is x times the square root of 3, which means that this side length is going to be 3 times the square root of 3 feet. Go ahead and take a moment, pause the video, and fill in the remaining missing sides for the other two triangles. In our third triangle, this side, our 2 inches, is our square root of 3x. So square root of 3 times x is equal to 2 inches. I can then solve for x by dividing both sides by the square root of 3. So x here is 2 over the square root of 3. So our shortest side, x, is going to be 2 over the square root of 3 inches. I'm not going to worry about rationalizing right now, but we could if we wanted to. Our longest side is then twice the length of that shorter side, so when I double my 2 over the square root of 3, I get 4 over the square root of 3 inches. In my last 45-45-90 degree triangle, I am given the hypotenuse, and I know that in a 45-45-90 triangle, the hypotenuse is equal to x times the square root of 2, so that's going to be equal to my 3 yards. To solve for x, I just divide by the square root of 2, and I have x being 3 over the square root of 2 yards. So I know that each of my legs is going to be 3 over the square root of 2 yards. And again, we could rationalize, but I'm not going to take the time to do that. We'll just leave it in the form that it's in. So we use the relationships between the sides of a 45, 45, 90 and a 30, 60, 90 degree triangle to complete the lengths of those sides. What we're going to do now is move on into sine, cosine, and tangent functions. You may have been exposed to our trig functions before, but I'm going to go ahead and walk us through these. In a right triangle, sine, cosine, and tangent simply take the ratio of two sides in that right triangle according to the measure of an angle in that triangle. So for example, if I'm looking at the angle T, this angle T will dictate the relationship between any two of the sides of this triangle. If T grows, increases in value, then my opposite side is going to become larger. The adjacent side will not change, but the opposite side and the hypotenuse will change. So this value of T changes and will dictate the relationship between the ratios of two sides. The ratios are found by using our sine, cosine, and tangent functions. Sine is specifically the relationship between the opposite side and the hypotenuse of our triangle. So as angle T might grow, that opposite side might grow and the hypotenuse would grow, so our value of sine would change. Sine is specifically the relationship between the opposite and the hypotenuse side depending on the value of your angle T. Cosine is the relationship between the adjacent leg and the hypotenuse, and tangent is going to be the relationship between the opposite and the adjacent side. We can remember which sides go with which trig function by using the mnemonic SOHCAHTOA. Sine is opposite hypotenuse, cosine is adjacent hypotenuse, and tangent is opposite and adjacent. SOHCAHTOA. So given the triangle below, I want to find the cosine of alpha. I want the relationship between the adjacent side and the hypotenuse of my right triangle. So we have two legs that we can pick from for opposite and adjacent, and those are the two that are attached to your 90-degree angle. So these are the two legs that are attached to my 90 degrees. One of them is opposite and one of them is adjacent. Since we're looking at alpha, my 30 is going to be opposite and my 16 is going to be adjacent. If we were starting over here at A, then the opposite and adjacent would be in different places. But starting at alpha, 30 is opposite and 16 is adjacent or touching. 34 is always my hypotenuse across from my 90-degree angle. So regardless, my hypotenuse is always across from that 90 degrees. So cosine is going to be the relationship between the adjacent side to the hypotenuse. So adjacent side is 16, hypotenuse is 34, and then I can reduce this down to 8/17. We don't know what the value of alpha is, but if alpha changes, then the value of our cosine will change. Since alpha is fixed, the value of our cosine is 8/17. Sine of alpha is going to be the opposite over the hypotenuse. So the opposite side is still 30, and my hypotenuse is still 34 since we are still looking at our alpha angle. So 30/34 reduces to 15/17. And then lastly, tangent of alpha. Tangent is my opposite, which is 30. Adjacent is 16, which reduces down to 15/8. All right, your turn. Take a moment. Go ahead and find cosine, sine, and tangent for alpha in each of the triangles shown here. Cosine of alpha is going to be the adjacent side over my hypotenuse. Since my two legs are 48 and 14, my adjacent side to alpha is going to be 48 over my hypotenuse, which is 50, and I can reduce this down to 24/25. Sine of alpha is going to be 14/50, which reduces down to 7/25. And tangent of alpha is going to be opposite, which is 14 over adjacent, which is 48, and that reduces down to 7/24. In our second triangle, the cosine of alpha Here's my alpha, the adjacent side, the adjacent leg. I need to pick between either my 36 or my 27. Adjacent means touching, so 27 is adjacent to my alpha over the hypotenuse, which is 45. And I can reduce by 3 to get 9/15. I can even reduce one step further and all the way down to 3/5. Sine of alpha is opposite over hypotenuse, so opposite is 36, hypotenuse is 45. I can reduce this by 9 to get 4/5, and tangent of alpha is opposite, which is 36 over adjacent, and I can reduce by 9 to get 4/3. We're going to do the same thing, find the value of cosine, sine, and tangent, except we're only given 2 of 3 sides. But that's okay. Since this is a right triangle, I can use the Pythagorean theorem to go ahead and find the missing side. So I've got A is 15, B I don't know, and C is 17. So A squared plus B squared equals C squared. And I can solve for B, which will be 8. So now that I have found B, I can go ahead and find the cosine, sine, and tangent of alpha. Cosine, if I use my acronym SOHCAHTOA, is adjacent over hypotenuse. So the adjacent leg to alpha is 15, hypotenuse is 17. Sine is opposite, which is 8 over hypotenuse, so 8 over 17. And tangent is opposite, which is 8 over adjacent, which is 15, so 8 over 15. Right, your turn. Pause the video and try out the next couple on your own. Our missing side here should be 4, giving us a cosine of alpha being 4/5. A sine of alpha is going to be 3/5. Tangent of alpha will be 3/4. Here our missing side is 7, so cosine of alpha would be adjacent over hypotenuse, so 7 over 7 square root 2, which I can reduce to 1 over rad 2. Sine of alpha will also be 7 over 7 rad 2, which reduces down to 1 over rad 2. And tangent of alpha would be 7 over 7, which simplifies to 1. Lastly, we're going to find the values of sine, cosine, and tangent using our special right triangles. So here I'm only given one of the sides of my right triangle, but I can find the other two by using the relationships between the angles and the sides of special right triangles. So hopefully we recall that a 45, 45, 90 degree triangle has the relationship where two of the legs are congruent, and the hypotenuse is that side length multiplied by the square root of 2. So in this case, my first leg is 3, which means the second leg is 3, which means that the hypotenuse must be 3 times the square root of 2. And now we can go through and find the cosine, sine, and tangent of our angle. Here I say alpha, but we'll go ahead and look at 45 degrees. So cosine would be adjacent over hypotenuse, so 3 over 3 rad 2, which is 1 over the square root of 2. Sine would also be 3 over 3 rad 2, which reduces to 1 over rad 2. And tangent opposite is 3 over adjacent, which is 3, which simplifies to 1. Go ahead, pause the video, recall the relationships for a 30, 60, 90, and find sine, cosine, and tangent for the angles given in each of these 1 and 2 examples. In a 30, 60, 90, the shortest side is going to be x, that's across from my 30. The middle side is x rad 3, and the hypotenuse is 2 times x. So across from the 30, I have my shortest side, which is x. Across from the 60 degrees, I have x times the square root of 3. So I can solve for x to get 17 over the square root of 3. So my hypotenuse is 2 times x, so 34 over the square root of 3, and x is 17 over the square root of 3, giving us the following three trig functions: cosine, sine, and tangent. And for number 2, our sine, cosine, and tangent values will be the values that I have shown here. That brings us to the end of our first video for section 6.2. Thanks so much for watching.